good afternoon, my beautiful grade 10s. Alright, so let's get into maths. Okay, the Lord has given us a beautiful day. Alright, it's nice and windy outside, nice and cold. Okay, so what's the best thing to do on a nice cold windy day? To do some maths. Alright, so if you look at today's topic, we're going to be doing or looking at the Cartesian plane. Alright, so what the heck is this thing? Alright, and it's where we are going to draw some triangles. Alright, so we're going to get into that just now. Okay, but what is this Cartesian plane thing? Alright, so let's get into that. So what is a Cartesian plane? Alright, so remember when you guys were doing graphs last year? Alright, you learned how to draw straight lines on a graph. Okay, as a graph. And you got something that looks like this. Alright, so the Cartesian plane is basically that. Okay, but now we're just going to be working with a few angles. Alright, so this is still your y-axis. Okay, this is still your x-axis. Alright, but here, if we're starting here, we're going to go around this way. Okay, and we're going to start at 0 degrees. Okay, we're going to go up to this is a 90-degree angle. Okay, so this over here is going to be 90 degrees. Okay, and then a full straight line if we go all the way down here. Okay, this is going to be my 180 degrees. Okay, to go all the way across to this line over here. Okay, that's going to be, so to go all the way from here to there. Alright, we're going to have 270 degrees. Okay, and if I'm going to make a full circle all the way around, okay, that's going to be back at 360. Alright, so this point here is 0, 360. There's 90 degrees, 180, and 270 degrees. Okay, so looking at that now. Okay, what does this exactly mean? Okay, what am I going to be doing here? Right, so there's those different trigonometric things that I showed you in the last video. Alright, so you know you've got sine, you've got cos, and you've got tan. Alright, so now let's see why we need the Cartesian plane and what does it exactly entail. Alright, so we're going to be doing some nice things with triangles, okay, using this Cartesian plane. Alright, so if I draw a triangle here, alright, in my first quadrant. Okay, so there's 4 different quadrants in the Cartesian plane. So you've got your first quadrant, which is over here, quadrant 1. Then you've got your second quadrant, quadrant 2, and quadrant 3, and quadrant 4. Okay, those are my 4 quadrants. Alright, and if I give you a triangle, okay, and I say that this is 2, okay, that's 1, and that's the square root of 3. Okay, or let's change that up. Let's say this is 1, sorry, and this is the square root of 3. Okay, so if I gave you that and I say please find sine, okay, of theta, let's call this theta. Okay, sine of theta. Alright, what are you going to say? You're going to say, okay, sine of theta, okay, is equal to opposite over hypotenuse. Okay, so opposite over hypotenuse, which is 1 over 2. Okay, if I said go find cos of theta for me, okay, we know that cos is adjacent over hypotenuse, so it's adjacent, which is square root of 3 over the hypotenuse, which is 2. Okay, and then if I say go find tan of theta for me, okay, what are you going to do then? Okay, that's opposite over adjacent. Okay, so it's opposite over adjacent, which is 1 over the square root of 3. Okay, so if I look at all of these values over here, alright, can you see that they are all positive? Alright, so there's positive there, they're all positives. Okay, there's no negatives here. Alright, so that means in quadrant 1, okay, any value that you get for sine, cos, or tan is going to be positive. Okay, so that means that all of them, I'm going to put an A there for all, okay, are all positive. Okay, they're all positive, all of them. Okay, now if I look at quadrant 2 and I draw another triangle, okay, draw another triangle, same triangle, and put 1 over there, we'll put 2 there. Okay, but now because I am this side of the x-axis, okay, so remember this is 0 if you're doing numbers now, 0, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the positives. Okay, and if I go backwards, okay, I'm going to have all the negative numbers. Okay, so now it's not square root of 3 anymore, it's now negative square root of 3 on this side. Okay, because I'm on the other side, okay, of my of my x-axis here. Alright, so again, if I look at this and I say that that is theta over there, okay, I want you to find sine of theta. Okay, so let's say sine of theta. What am I doing? Okay, sine of theta. Alright, and we know that that is opposite over hypotenuse, so that again is 1 over 2. Looking at this angle now, opposite hypotenuse. Alright, and if I say go find cos of theta, okay, we know that that is adjacent over hypotenuse. And now we see, okay, now we see that cos is now a negative something. Alright, so negative square root of 3 over 2. Okay, so now that's a little bit different than the first quadrant. Okay, so now let's see what happens with tan. Alright, tan of theta. Alright, we know is opposite over adjacent, so now we're going to say opposite, which is 1, okay, over the negative square root of 3. Okay, so I like to put my negatives here in front of the fraction. Okay, I don't like to put them at the top or at the bottom, so just take them out, just put them on the side here. Don't give the negative to either the top or the bottom. Okay, so it doesn't really matter. Okay, just put it there on the side. Okay, alright, so I know, so what I mean is, this is what I mean. So some kids, what they do is, okay, it's positive square root 3 over negative 2. Okay, a lot of kids do that. I'm going to tell you now, it's going to help you a lot, especially in trigonometry, to take that negative and just put it over there on the side. So don't put it underneath or on top, just put it on the side there somewhere. Okay, it's going to help you a lot. Okay, so now if I look at these ratios over here, okay, so I see that sine is positive, okay, we see that cos is negative and tan is negative. Okay, so which is the only ratio that is positive here in quadrant 2? Okay, only sine is positive, right? Only sine is positive there. Okay, cos and tan, they're both negative. Okay, it's important to note. You'll see why later. Okay, so if I now draw another triangle, okay, and I'm now in the third quadrant, okay, I'm going to draw a triangle here, and I call that theta. Okay, I've got the negative square root of 3 over there. 2 stays there. Okay, and now if you look at my y values, okay, so if I'm going above the x-axis, okay, I know I'm positive, but if I go below the x-axis, if I go below the x-axis, we know that my y values are negative, so this is going to be negative 1 now. Okay, so please note that. Alright, and these are all 90-degree triangles, sorry. Alright, so please make sure that you understand that. Okay, so when you're drawing your triangles later on, that is very important to note. Okay, so please always check where are you. Okay, what is my x values, what are my y values. Okay, it's very important. Okay, so now I want you to do the same thing. Okay, so sine of theta, I want you to find sine of theta for me. Now with this triangle that's in the third quadrant, okay, we know that sine of theta, again, sine is what? Opposite over hypotenuse. Okay, so we know it's negative 1 over 2. So if I look at this, this is my angle now, theta. Okay, opposite over hypotenuse. Okay, so we've got negative 1 over 2. So I'm going to take that negative out and just put it on the side there. That's 1 over 2. Alright, if I do cos of theta, okay, we know we can say cos of theta is adjacent over hypotenuse. So it's adjacent, which is the negative square root of 3 over 2. Sorry, negative square root of 3 over the hypotenuse, which is the 2. There's the 2. Okay, so it's negative square root of 3 over 2. Alright, and if I look at tan of theta, alright, tan is opposite over adjacent, so I'm going to go opposite my angle, which is negative 1. Right, so it's negative 1 over the negative square root of 3, negative square root of 3. Alright, and that's my adjacent side. And now we know that a negative over a negative is a positive. Okay, so it's positive 1 over square root of 3. Alright, so which is the only one that is positive here in the third quadrant? Okay, we can see that only tan is positive. So I'm going to say only tan is positive, okay, in the third quadrant, because sine and cos are both negative, and they will always be negative. Alright, so now if I do my last one, I draw my triangle again. Okay, now I'm in the fourth quadrant. It's also 90 degrees. That's going to be negative 1. That's going to be 2. That's going to be theta now. And we've got the square root of 3. Alright, so what I want you to note as well is that the hypotenuse of all my triangles, the hypotenuse here, okay, the angle that's opposite the 90 degrees, my hypotenuse is always positive. Can you see that? Okay, that is important to note. Okay, please If you did not notice that, okay, maybe circle it, okay, and just remind yourself, okay, it's always positive, please, okay, always positive, okay. The only ones that change are my x values and my y values here, so my horizontal values, right, or my vertical values, okay, they will change. Alright, so if I look at theta here, okay, and I say, okay, go find sine of theta for me. Alright, sine of theta we know is opposite over hypotenuse, so it's opposite, which is -1 over the hypotenuse, which is 2, positive 2. Alright, so we can see that sine is negative, okay, so let's see what cos does. Let's see what happens with cos of theta. Okay, cos is adjacent over hypotenuse, so we've got the positive square root of 3 over the hypotenuse, which is always positive. So now we can see that cos is now positive. Right, let's see what happens with tan. Okay, so we've got tan of theta, okay, equals, which is my opposite over adjacent, which is -1 over square root of 3. So it's -1 over square root of 3. Alright, so we can see that cos is the only one that is positive there. So we can see that cos is always positive. Okay, so basically what we've done, alright, is now we have proven, okay, where my different ratios are positive, okay, and where they are negative. Alright, so we know that in quadrant 1, okay, quadrant 1 over here, okay, we know that all my ratios are going to be positive. Okay, we know that all of them are going to be positive. That's very important to note, and you'll see why. Right, all of them are positive here. Alright, and we look at quadrant 2, we know that only sine is positive. That means that cos and tan are both negative. Okay, if only sine is positive. In my third quadrant, tan is positive. Okay, that means that sine and cos are both negative. Right, and if I look at my fourth quadrant here, we see that only cos is positive. Okay, but tan and sine are both negative. Alright, so a nice easy thing that you can remember, okay, to remember, okay, where's all my positive things, okay, is to remember cast. Alright, so you can remember cast, okay, but you must remember to start in the fourth quadrant. Okay, so if I go around this way, and I'm starting here, so I've got C, A, S, T, and there's my cast. Alright, so you can remember cast. Alright, so that's very important to note. Please learn that. Okay, make sure that you know where cos is positive, where all of them are positive, where's sine positive, where's tan positive. Alright, and knowing that where they are positive, these certain ones, you know where they are also negative now as well. Alright, so now let's see the application of this. Okay, why did we learn this? Alright, so if we look at this, okay, we're going to be finding ratios using a sketch. Alright, so if I say, okay, I'm going to give you that tan of A is equal to 5 over 12. Okay, can you see that what I've given you here? So I know that tan of theta, tan of A, not tan of theta, tan of A is equal to positive, okay, positive 5 over 12. So now I just want to see something. Let's see if you remember my previous slide, all right? So where is tan positive? It's positive in which quadrants? There's 4 quadrants. Where's tan positive? In the first quadrant and the third quadrant. Okay, let's just go back quickly. Okay, so all of them, so sine, cos, and tan are all positive in the first quadrant. Okay, and only tan is positive in the third quadrant. Okay, so if they tell me that tan of A is a positive fraction, now I know which quadrants I'm in. Okay, so I'm either in quadrant 1 or I'm in quadrant 3. Okay, but now I can't choose both of them, because if you look here, my previous slide, okay, I could only draw one triangle, okay, at a time. Okay, so I drew in my first quadrant, I drew one triangle, okay, and I found all my ratios. Okay, and then in quadrant 2, I drew another triangle and I found all my ratios. So I need one triangle in the sense. Okay, so if I look at the rest of the question, so I look at this, okay, they say that angle A is greater than 90 degrees. Okay, so remember with my Cartesian plane, I've got degrees here. So I've got 0 degrees, I've got 90 degrees, 180 degrees, 270 degrees. Right, there's all degrees. Okay, and I'm back at 360 degrees. Okay, so if they say that A is greater than 90, and A starts here. So if I go up this way, I'm starting at 0, and I'm going up until 90 degrees, okay, and then I'm going to go to 180 degrees and 270 until I get all the way to 360. So if I'm going that way, going anti-clockwise, alright, and we know that A is greater than 90, okay, where am I? Which quadrants could I possibly be in, right? Can I be in quadrant 1? No, because in quadrant 1, my angle, okay, my angle is smaller than 90 degrees, okay, here's 90, so if I go backwards, I'm going to 80, 70, 60, 50, 40, 30, 20, 10 degrees, and eventually to 0, right? So if I'm greater than 90, okay, if my angle has to be greater than 90, where am I? I'm here, I'm greater than 90, right? So I'm either in the second quadrant, or the third, or the fourth, alright? Okay, because greater than 90, okay, is all of these angles here, okay? Okay, so if I'm in either the second, the third, or the fourth, which quadrant am I going to be drawing my triangle in if tan has to be positive? Okay, we know I have to draw it in the third quadrant because I can't draw it in the second. Why can't I draw it in the second? Because tan is negative, and here they've given me that tan of A is positive. Alright, second quadrant it's negative, tan is negative, and in the fourth quadrant tan is negative. So the only possible quadrant that I could be in is my third quadrant. Alright, so I hope that makes sense. Alright, so I'm going to draw a nice triangle here. Alright, a nice 90-degree triangle. Alright, and technically this is angle A over here. Okay, that's angle A. Alright, so but what I want you to actually think about, because that confuses some students, alright, is just to imagine this angle here. I'm looking at this angle here of my triangle always. Alright, so I'm going to call this angle A just in a sense, alright, because I know that that other one confuses you. Alright, so just look at that over there. Alright, so I'm looking at this angle here. Alright, and they say that tan of A is equal to 5 over 12. Alright, so what is tan? Is it opposite over adjacent, or what is it? It is exactly that. Okay, it's opposite over adjacent. Alright, so we know that's opposite over adjacent. So my opposite side, opposite this angle, is going to be my 5. Okay, so opposite that, it's going to be 5. Okay, and adjacent to this angle, which is over here, is going to be 12. Right, but I want you to quickly just look, where am I on my Cartesian plane? All right, on my x-axis, okay, am I to the right of my y-axis, or am I to the left of my y-axis? Okay, I'm to the left. That means what? That these values, my horizontal values here, okay, are all negative. And I want you to check, where's this 5? Is it above my x-axis, or is it below the x-axis? Below, meaning that this 5 has to be negative. Alright, so if I look at it again, tan, okay, it's negative 5 over negative 12, and a negative divided by a negative is a positive. That's where the positive comes from. Alright, but if you look at these triangles over here, we know that we had a hypotenuse. We had a value for the hypotenuse always. Alright, so if I look at this, how am I going to find the value of my hypotenuse here? Okay, if I'm working in a 90-degree triangle. Right, I can use Pythagoras. Alright, so if I'm looking for, okay, I'm going to call my hypotenuse just hype. Okay, hype. Okay, we know it's going to be the square root, okay, of negative 12 squared plus negative 5 squared. Alright, and that's going to be because of Pythagoras. Okay, so that's 90 degrees and my y-axis. Okay. Okay, looking at that now, we know that that's going to give me 13. Okay, so I know that my hypotenuse is 13. Alright, so now we've drawn our triangle. Fantastic. Alright, I hope that makes sense of how I drew my triangle. The more examples you do, the easier it will become. Right, because I know this is a new topic for you for the grade 10s. Alright, so we're going to do 2 more examples, and then hopefully you get it by then. Alright, so now I can ask you anything now, okay, because now I have a triangle, cool, and I have all my sides, and I know what angle A is, and I know where angle A is, okay, I know what angle I'm using. Alright, so if I say, okay, go find sine of A for me, okay, so I'm going to go to my triangle, cool, and they say I must find sine of A. I know that sine is opposite over hypotenuse, okay, so it's opposite over hypotenuse, which is negative 5 over 13. Okay, and that's as easy as that. Right, if I say go find cos for me, okay, cos of A, okay, please always remember that your sine, your cos, or your tan always has an angle attached to it. So don't just write cos equals, okay, that means nothing to me. Okay, cos of an angle, cos of A, sine of A, tan of A. Please always put that in. Students don't do that, okay, and you lose marks. Alright, so now cos of A, if I'm talking about cos, I know it's adjacent over hypotenuse. Alright, so adjacent over hypotenuse, so I know it's negative 12 over 13. Right, and now if I say, okay, go find sine squared of A plus cos squared of A, okay, how would you do that? Okay, firstly, I know what sine is. Okay, sine of A, they say it's negative 5 over 3, but now they say it's squared. Okay, so I'm going to say it's sine of A is negative 5 over 13, and then I'm just going to square it. Alright, and then they say, okay, cos squared of A, I know what cos is. Okay, cos of A is negative 12 over 13. Okay, but they squared it, so I'm just going to square it. Alright, so that's going to give me 25 over 169. That's going to give me 144 over 169. And 144 over 169 plus 25 over 169 is 1. Okay, so it's 169 over 169, which is just 1. Alright, so I hope that's making sense. Alright, so if it's still a bit fuzzy in your brain, okay, please just rewind the video, just watch it again. I know it's going to take some time to get used to. Alright, and that's okay. So hopefully in the next example you guys are with me. Alright, so it's just learning work, firstly. So you need to learn where is cos positive, where is tan positive, where is tan negative, where is this positive, where is that negative. Alright, so look at the next example. Okay, so now they give me a point. Okay, so instead of giving me tan of A is equal to something, okay, they actually go and they say, okay, point P is this. Alright, so do you guys remember how to plot points? Okay, plotting points. Okay, so let's go plot this point for me. Okay, so the first number is what? Is it my X or my Y value? It's my X value. Okay, and the second value is my Y value. So if I'm going on my X axis, here's my X axis. Here's my Y axis. Alright, so my X, okay, is on this axis over here. So if it's negative 12, am I this side or am I this side? Am I to the right or to the left? I'm to the left of my y-axis. So I'm going to go to negative 12. Let's say that's negative 12 over there. Alright, and my y-axis is negative 5. So am I above my x-axis over here or am I below my x-axis over here? I'm below, okay, because it's negative 5. So let's say that over there is negative 5. Okay, and I'll plot my dot over there. Right, and that point, okay, we know is negative 12 and negative 5. Okay, so now how am I going to draw a triangle now? Okay, so now I have a dot. Okay, how am I going to turn this dot into a triangle? Right, I'm just going to connect it to the origin. Alright, can you see that this is now my hypotenuse? Okay, so if you look at all these triangles I drew, my hypotenuse is connected to my origin. Okay, my hypotenuse, okay, is connected to my origin. Okay, all these hypotenuses, okay, are all connected to my origin. Alright, so looking at this now, just connected to the origin, and now I can draw my little triangle. Okay, and we know that that's 90 degrees there. Okay, and let's call, so again, I'm going to say this again, this is angle A. Okay, that's angle A, but I know that confuses you. Okay, so I just want you to look at this angle. We're always looking at this angle. Okay, the angle closest to my origin. of the triangle. Okay, and another question somebody asked me in the class, in my class, right? We only draw these triangles, okay, connected to the horizontal axis. Okay, so he said, "Sir, why can't I draw my triangle like this? Okay, connected to the vertical axis." And I said, "Because I said so." All right, please don't draw your triangles like that. Okay, you'll understand later why. All right, so please always connect your triangles, okay, to your horizontal axis. Okay, so it needs to, this 90 degrees has to be touching my horizontal axis always, never my vertical. Okay. All right. So now, what am I going to do now? How am I going to put my values in? Right. So we know that this first value of my point is my x value. Okay. So if that is my x value, where's my x value on my triangle? Okay. It's my horizontal value. Okay. Horizontal. So on my horizontal axis, I know that this is negative 12. Right, and then my negative 5, we know it's my y value. Okay, so my y values are all my vertical values. Alright, so my vertical values is over here. So I know that that is negative 5. Right, and then how am I going to find this value over here? Okay, we can say, okay, because we know from the previous one, okay, we know it's 13. Okay, using Pythag. Okay, don't be lazy like I am now. Okay, so please always just put in your working out. Alright, so we say it's the square root of negative 12 squared plus negative 5 squared. We know that's Pythagoras. Okay, always put this reason there. Alright, don't lose marks for stupid things. Alright, we know that that's 13. Alright, now I can ask you any question and I can say, alright, go find tan of theta for me. Yeah, we can call it theta, let's call it theta. Okay, because it doesn't really matter. Okay, unless they tell you. So in the previous question they told you it was angle A. Yeah, they don't say anything, so I'm just going to call it theta. I can call it A, I can call it B, whatever you want. Okay, so I'm just going to call it theta for now. Okay, so tan of theta, we know tan is opposite over adjacent. Okay, so we know that's negative 5 over negative 12. So negative 5 over negative 12, and a negative over a negative is a positive 5 over 12. Right, if I say go and find sec of theta, alright, so let's just call that theta. Right, sec of theta, we know that sec is the reciprocal of cos, and we know that cos is adjacent over hypotenuse, so the reciprocal of that is going to be hypotenuse over adjacent. Alright, so we know it's hypotenuse, which is 13, over the adjacent side over there. Okay, so they can ask you reciprocals, alright? The reciprocals of cos, sine, or tan. Alright, that's a very common thing to do. Alright, so let's look at this example over here. Alright, so here we see that we've got 3 plus 4 sine of A is equal to 0. And we see that A is smaller than 270 degrees. Alright, nice. Alright, so let's see how we're going to, let's work this out. Alright, so if you look at my first example that I gave you, alright, I said tan of A, okay, is equal to a fraction. Right, so tan of A is equal to a fraction. Alright, so here I've got 3 plus 4 sine of A equals 0. Alright, so what do I want to get? I want to get sine of A equal to a fraction. Alright, so let's see if we can do that. Okay, so we're going to take the 3 across. Alright, so we've got 4 sine of A is equal to negative 3. And then I want to get sine of A by itself, so I need to divide by 4 on both sides. Okay, so I've got sine of A is equal to negative 3 over 4. Alright, now I've got sine of A is equal to a fraction. Nice. Alright, but they also say that angle A is smaller than 270. Alright, so where am I? Okay, if angle A is smaller than 270, so we know that that's 0, that's 90, that's 180, okay, and that is 270. So if I'm smaller than 270, okay, which quadrants am I in? Okay, smaller than Smaller than 270 is this way, right? All of these quadrants over here. Alright, so that means I'm in quadrant 3, I'm in quadrant 2, or I'm in quadrant 1. Okay, now we have to decide, okay, which one am I in? Now let's see. Right, so they say that sine of A is negative 3 over 4. Alright, so in quadrant 1, 2, or 3, where is sine negative? Alright, so we know that all of them are positive here. We know that only sine is positive here. Alright, so that means that sine of A is negative in the third one, because what is the only ratio that is positive in the third quadrant? Tan, alright, if you remember cost. Okay, nice. Okay, so that means I'm working here in my third quadrant. This is the quadrant I'm going to draw my sketch. Okay, I'm going to draw my triangle. Alright, so I'm going to start by doing that. Draw my triangle, nice 90 degrees. Alright, so this is angle A. Okay, angle A. Alright, and I'm not going to change this now. Okay, I'm going to leave it as angle A. Alright, and we know that sine of A, okay, is equal to negative 3 over 4. Okay, so we know that sine of A is firstly what? What is the ratio for sine of A? Opposite over hypotenuse. Okay, so we've got opposite over hypotenuse. Okay, so we've got negative 3 over my hypotenuse, which is always positive. Okay, and how are we going to find this last side over here? Okay, we have to use Pythagoras, right? So if we're looking for the adjacent side, we'll call it A, right? Now we're going to have the square root of 4 squared minus negative 3 squared. Okay, we know that that reason there is pi bang. Alright, so we know that the square of 4 is 16. Okay, and we know the square of negative 3 is 9. Alright, which is, we know that that's 7. Okay, so it's just the square root of 7. Right, so I'm just going to write in there the square root of 7. Okay, but I want to see first, I need to check all these sides over here firstly. I need to check all the values. Right, so where am I here with this negative, well, with this square root of 7? Okay, I'm on the negative side, next the negative x values. Right, so it needs to be negative square root of 7. Down below, right, so it's negative 3, that's right. Okay, and my hypotenuse is always positive. Cool beans. Alright, so if I can now ask you anything, okay, so I want you to go and find cos of A for me. Find cos of A. Okay, so I'm working with this angle, remember? Just this angle here. Okay, so cos, we know it's adjacent over hypotenuse. So it's negative square root of 7 over 4. Okay, and if I tell you to go find cosec of A, okay, we know cosec is the reciprocal of sine. Right, so if we know what sine is, what is sine? Sine is firstly opposite over hypotenuse. Okay, so cosec is going to be the reciprocal of that, which is hypotenuse over opposite, which is 4 over negative 3. 4 over negative 3. Alright, okay, so now that's finding ratios using a sketch. So I hope this video was beneficial for you guys, and I hope it's been helping you guys. Alright, so first thing first, alright, you need to first learn your Cartesian plane. You need to know where these things are positive, where they are negative. Okay, because that's going to help you determine what? Where to draw my triangle. Alright, so please, you need to learn. Okay, all of them are positive here. Sine is positive here. Tan is there. Cos is positive there. Alright, please learn that. Okay, please learn where 90 degrees is. If I'm lower than 90 degrees, I'm in the first quadrant. Okay, if I'm smaller than 180 degrees, I'm in quadrant 1 and 2. If I'm greater than 180 degrees, quadrant 3 and 4. Alright, so please go and learn those things. Go and wrestle with them. Alright, and yeah, I hope that this video was beneficial for you guys.